Hello students. Today we will discuss the systematic qualitative analysis of anions and cations which are present in different salts. In salt, the anions are also termed acidic radicals, while cations are also termed basic radicals. Anions are divided into two categories, Class A and Class B, based on their response to mineral acids. Class A is further divided into A1 and A2. A1 category anions react with dilute acids, while category A2 reacts with concentrated acids. The radicals which belong to these categories are as follows. Carbonate, sulfide and acetate belong to class A1. Chloride, bromide, iodide, nitrate to class A2. And sulfate to class B. When we consider the basic radicals, then they are also divided into 6 groups, based on their response to certain reagents. Let us see a few examples of these groups. Ag plus and Pb2 plus belongs to the first group. Cupric ion belongs to the second A group. Second B group doesn't contain any common cations in it. Next is the third group, which has ferric, aluminium 3 plus, and last is chromium 3 plus. Followed by these are the fourth group, which has Zn2 plus, Mn2 plus, and Ni2 plus. Further, group fifth has barium 2 plus and calcium 2 plus. Finally, the sixth group has Mg2 plus, NH4 plus, Na plus, and K plus. Now, let us analyze the anionic radicals first. First is the carbonate, which in reaction with dilute HCl evolves CO2 gas, and a brisk effervescence can be observed. When the carbon dioxide thus released is passed through slaked lime or baryta water, it turns milky. In the case of slaked lime, on excess passage of CO2, it again becomes colorless, as formed calcium bicarbonate is soluble in water. Similarly, when the carbonate reacts with barium chloride, calcium chloride or silver nitrate solution, it gives a corresponding precipitate of carbonate. Silver carbonate, thus formed, on further heating, forms a yellow or brown precipitate of silver oxide and CO2 gas is released. Next is sulfide. With dilute HCl or dilute H2SO4, it forms H2S gas, having a rotten egg smell. This H2S gas, when passed through lead acetate or silver nitrate solution, gives a black precipitate. Last, in class A1 is acetate ion, which with dilute sulfuric acid, gives vinegar. When this solution is added with NaOH, it gives sodium acetate, which in reaction with ferric chloride gives a deep red color solution. First, to analyze in class A2, is chloride. With concentrated sulfuric acid, it gives HCl gas, which is corrosive in nature, and will be colorless, to slightly yellow in color. This gas can turn blue litmus red, and gives dense white fumes of NH4Cl, when a glass rod moistened with ammonia solution is brought to the mouth of the test tube. While with manganese dioxide and concentrated sulfuric acid, it releases yellowish-green gas, chlorine gas. Also, chloride ion with silver nitrate or lead acetate gives white precipitates. White PPT of AgCl is soluble in ammonia solution. The second one is bromide ion, which with concentrated sulfuric acid or manganese dioxide and concentrated sulfuric acid will release reddish-brown vapors of bromine gas. While with silver nitrate solution, it will give curdy pale yellow PPT of AgBr, which is sparingly soluble in ammonia solution. While with lead acetate, it gives white crystalline precipitate. And, with chlorine water in chloroform, it gives an orange red color solution. Next is iodide, with concentrated sulfuric acid, or potassium dichromate, and concentrated sulfuric acid, gives violet vapors of iodine. While with silver nitrate solution or lead acetate solution, it gives a yellow, curdy precipitate. And, with chlorine water in chloroform, it gives a violet color solution of iodine. Last in this class is nitrate, which with concentrated sulfuric acid, gives reddish vapors of nitrogen dioxide. While with ferric chloride in the presence of concentrated sulfuric acid, it will give a brown ring complex, which on shaking or warming, gives a yellow solution. In class B, we need to see sulfate ion, which when reacts with barium chloride solution, gives a white precipitate of barium sulfate, that is insoluble in warm dilute hydrochloric acid and in dilute nitric acid, but moderately soluble in boiling, concentrated hydrochloric acid. After acidic radical, next we need to learn about the basic radicals. The group 1 reagent is dilute HCl. That of 2A and B is hydrogen sulfide. For group 3 ions is ammonium hydroxide and ammonium chloride. For fourth group, it is H2S in the presence of NH4OH. Next is the group 5 reagent, which is ammonium carbonate in ammonium hydroxide solution. While sixth group it is ion specific. Let us see the confirmatory test. For this, we can take the precipitate or the product of group analysis or the compound itself for performing the test. First is lead chloride PPT, which gives a yellow precipitate with both potassium chromate and potassium iodide. The yellow PPT of lead chromate is soluble in NaOH solution. Next is AgCl, which is soluble in ammonia solution. For cupric ion, when its salt is added into ammonia solution, a deep blue color solution is obtained. While potassium ferrocyanide gives chocolate color precipitate. Next is the ferric ion. The precipitate reacts with HCl to form ferric chloride, which, when reacts with thiocyanate, gives blood red color. With potassium ferrocyanide, it gives Prussian blue color. Further, we see chromium 3 hydroxide reacts with alkaline bromine water, followed by barium chloride, to give a yellow precipitate of barium chromate. Next, aluminium hydroxide precipitate, when dissolved in alkali, becomes soluble due to the formation of sodium aluminate. Likewise, ZnS precipitate with alkali forms soluble sodium zincate. Manganese compound will form the precipitate even when it reacts with NaOH, which when heated will give brown or black color due to the formation of MnO2. Nickel compound, when reacts with potassium bicarbonate, forms an apple green color solution, which when oxidized in alkaline solution will form a black PPT of nickel 3 oxide. While barium compound forms two different PPT with potassium chromate and ammonium sulfate. Next is calcium, which with ammonium oxalate gives white PPT of calcium oxalate. Magnesium compound, when dissolved in the ammonia aqueous solution, forms a white gelatinous precipitate of magnesium hydroxide. Next is the ammonium compound, which, when dissolved in an alkaline solution, gives a smell of NH3. The gas evolves white fumes with HCl. When a paper is soaked in CuSO4 solution, it becomes deep blue by NH3 due to the complex formation. With Nessler's reagent, a brown PPT is obtained. After this is sodium compound, in which sodium ion reacts with potassium dihydrogen antimonate to give heavy white PPT. Lastly, potassium ion reacts with sodium cobalt nitrite to form yellow PPT. Let us summarize. Acidic radicals are classified into class A and class B based on their reactivity with mineral acids, while the basic radicals are classified into 6 groups based on their ability to precipitate in the presence of a particular reagent.